Hello and welcome back to Math with Patrick. Today we'll be talking about Stardew Valley, of course. Right now, I'm in the middle of a challenge run where I'm trying to reach perfection as soon as the game lets me. Perfection is kind of like the end of the game. Once you've completed almost everything, you will have reached perfection. One of the things that you need to complete is the community center, and to complete the community center, you need to bring items from all around the game into this building and put them in bundles. One particular bundle that's mathematically interesting is called the Quality Crops bundle. Here we need to get 5 quality parsnip, melons, pumpkins, or corn. I do say or, but we basically need to choose which one we don't want, because there are 3 open spots and 4 possible crops for us to place in here. And by quality, I just mean we need that little gold star in the bottom left corner. At this point in my run, I've basically gotten the parsnips, so I don't need to worry about spring crops. And as I'm trying to get this as soon as possible, I want to fill the other 2 spots with the melon and the corn because the summer crops come before the fall crops. Gold quality crops aren't that hard to come by, it's just that with a lower farming level, you don't get them as often. Right now I'm projected to be about farming level 6 when I'm harvesting the corn and the melons, which gives me a certain percentage expectation of getting regular silver or gold quality crops. You can also eat food items in the game that raise your farming level, and so I can be pretty certain that I'll have the right food item to raise it 3 levels up to 9. That gives me an increased chance of gold quality crops at level 9 compared to 6. And those percentages are so close to nice round numbers that for now, let's just assume that the silver quality is 30% and the gold quality is 20%, and we'll worry about changing the numbers back later. So let's use these percentages and see what might happen if we grow a sample amount of crops. Let's choose corn for the example, and let's say we planted 10 of them. A 20% chance is the same as 1 in 5, a 30% chance is the same as 3 out of 10, so maybe it would make more sense to call the 1 out of 5 2 out of 10 instead. And with a 50% chance of getting regular crops, we can expect 5 out of those 10 to be regular quality. Although it doesn't really matter if we get silver or regular, it just matters that they're not gold. So we can really just worry about the 20% chance for gold and the 80% chance of not getting a gold quality crop. So we could just take these proportions and scale it up until we find 5 gold star quality corn, and with 25 crops, 5 are going to be gold quality, right? And the answer to that question is kind of. So with 25 corn crops, with this particular percentage of getting a gold star quality corn, we will get roughly 5 gold star corn on average. This doesn't yet mean that we know how certain we are that we're going to get at least 5. See, the question is a bit different. I want to know how certain or how probable it is that I get 5 or more, because, well, 4 or fewer isn't enough, and I need to guarantee that I have at least 5. So the first thing we could investigate is the individual probability of getting 0 or 1 or 2 or so on. And with 0, it's fairly easy to think about. We just need to take the percentage of not getting a gold star corn crop, which is about 80%. And, well, assuming these events are independent, and I'll get back to that in a sec, I can just multiply the probabilities together, 80% times 80% times 80%, 25 times over, because we have those 25 crops, and that will give me the number of the probability of getting, well, no gold star corn. The probability there turns out to be quite low, about 0.4%, and we can actually use the same thinking on the other side of our graph and figure out the probability of getting 25 gold star corn. And here it should be really clear that the probability should be really close to 0, because it's not even that likely that we get 1 gold star corn out of 1 corn. So the fact that we would get 25 out of 25 all gold is almost 0. And then, how do we fill out the middle, though? Like, we could be a little bit sure that 5 should be some kind of probabilistic maximum here, because it's the most common number or the average that we should expect. So maybe our probability distribution would look something like this. So let's see what we can do to try to figure out where to place those dots kind of in the middle between the 0 and the 25. And if you know math well, and here you're telling me to use a binomial probability distribution, you would be right, but I want to generate these numbers, ourselves. I want to see where they're actually coming from. So the first thing that we should look at is what's the probability of getting just one gold star corn? And we can think through of it with a little bit of multiplication. The first number that we should put here is the number of ways we could choose one gold star corn amongst the field of 25, and clearly there's 25 different ways to do that, not 50. Don't worry, I fixed that later. There's going to be 25 unique scenarios of us getting one gold star corn, and it just comes from the different possibilities of where to choose that one gold star corn amongst the field of 25. Then, once we have those 25 different options, we'll multiply by that 0.2 that represents the 20% chance that that one corn is gold star, and we'll multiply by 0.8 to the power of 24. The 0.8 is a chance that all the others are not gold, and we're multiplying that 24 times over, because there's 24 corn that aren't gold star. And I would like the right side of the table, those entries, to all look roughly the same. So let's rewrite our first one in a format that looks a little bit closer to the second one. And the leading one right here is just counting the number of ways that we could have no gold star corn in the field. And there really is only one outcome that does that, and it's that the whole field is just trash. So that 1 and that 25, not 50, are counting the number of ways that we could get 0 and then 1 gold star corn. Let's try counting up the number of ways we could get 2 gold star corns in the field. My preferred way of thinking about this is thinking about walking around the field of corn and just counting the number of ways we could place these 2 gold stars. At first, we could place this gold star anywhere, so we have 25 options for the first one. But once we're trying to place the second gold star on a piece of corn, we can't just re-choose the same corn that we already chose. So the second gold star has only 24 options. And then finally, it doesn't really matter if we chose corn A before corn B, or corn B and then corn A. Like, the order doesn't really matter of how we placed them. And so we want to divide by 2 here because there are 2 distinct scenarios, if the order mattered, that we're trying to kind of divide out or count as the same. Okay, let's do the same thing for 3 gold stars, and at this point I'm trying to find a little bit of a shorthand for this, because as we walk through the steps we get 25 times 24 times 23 in our numerator, and then in our denominator, when we're dividing out the identical scenarios, we can see that there are 6 different ways to order 3 objects. And so there are going to be 6 different methods of going out in the field and assigning a gold star to our corn that are all functionally the same. This descending product would get a little bit unwieldy for bigger and bigger numbers, so it would be useful to have some kind of shorthand. Here we could first think about using factorials to describe what this product is doing. In the numerator, we could think about it as 25 times 24 all the way down to 21 and call this 25 factorial. This is just the definition of a factorial. Then, to make sure that we stop at 23 right here, we can divide out 22 all the way down to 1 by dividing by 22 factorial. Then, to make sure that we're still considering that 3 times 2 times 1 that we have there, the number of ways to scramble 3 things, I'll also include a 3 factorial in the denominator. There are many ways to call this. You could call it a choose function, you could call it a binomial coefficient. I am going to use the last notation here just because it's the most concise. Now that we have this concise notation that counts the number of ways we can choose what gold stars happen in our field of 25, I can backtrack and just replace all of those numbers with these binomial coefficients. And 25 choose 0 is still equal to 1. There's exactly one way you can choose nothing from a group of 25, and that's just doing nothing. That counts as an option. And now that we have this general form, we can keep generalizing, and instead of thinking about an actual number of gold corn crops, we can think of a variable, n gold corn crops in our field of 25. And following the pattern, we can get an expression that gives us the probability of n gold corn showing up. Okay, we got really down in the weeds with the numbers and the formulas. Let's get back to what we're actually trying to solve. we need to make sure that we have 5 or more gold star corn crops when we harvest our corn. And each of these expressions counts as the probability of getting, say, 5 or 6 or 7 gold star corn. So I want to add up all of these probabilities from 5 to 25 using this general form that I wrote to get the probability of getting between 5 and 25. Those are all the successes that I want. 0 through 4 are all the things I don't want. However, I don't want to write out the sum of 21 different things, so it's better to use summation notation right here to concisely write our sum. So this notation is saying that we're going to add this expression to itself over and over again when I is equal to 5 and then 6, and then we're going to increment it all the way up to that 25 on top. And now's probably a good time to substitute out that 20% and bring back the 19% that's actually accurate for my in-game probability. And once we're able to sum it all up, I'm just using a calculator here, I'm not doing this myself, we get 52.9%. That's super low. Like with a field of 25 corn crops, what this means is that I have a barely more than half chance of getting the 5 gold star corn crops that I want. So of course, I'd like to increase this chance. I want a higher chance of actually having a successful Stardew run here. And could we get like a 90% chance, or could we get a 100% chance? Well, okay, not 100%. There's no way for us to absolutely guarantee that we get 5 or at least 5 gold star corn, because there's always a chance, even with the highest farming level, that we just don't pick up any gold star corn crops based on the probability. Oh, and one more thing we could do to our sum to kind of clean it up is that we could actually sum up the chance of getting what we don't want, and then just doing 1 minus the probability of what we don't want, because that would still give us the probability of what we do want. This formula is better because it's only a sum of 5 things instead of 21 things. And as we vary that number 25, I'd rather not vary the amount of things I'm adding. I'd rather just keep it the same as 5 things that we're adding in the sum. And as we increase this x from 25 to a bigger number, we won't see this probability hit 100, but we are going to get closer and closer to 100. However, I can't just needlessly increase it, because Stardew farms do come with some limitations. So this is a little mock-up of what I think my farm will look like when I'm harvesting these corn and melon crops. I'm just using melons here for the mock-up. By doing a little bit of multiplication to solve for area, and then subtracting out some blank spots that I can't actually farm on, and then also subtracting out space for those scarecrows, you can see that I have about 80 crops in those 2 locations, and then around 200 odd crops in the bigger plot. So 25 corn crops, of course, is reasonable. I could even do like upwards of 80, right? I could do 80 melons there, 80 corn there, and then have the rest of the space for other crops. But I'd like to not go overboard on this number. I'd like to know a reasonable maximum that still gives me more than enough chance to secure my 5 corn crops and melons with a gold star. So now we have a goal. Let's replace the 25 with x so that it can vary, and then we could put it on a graph and visually see what's going on. And we could see when our probability of success is higher than certain benchmarks. Let's see how many corn we need to plant to get a 90% or 95 or 99% chance of success. Here I'm using the expression to just verify that 52.9% from earlier, and now we can stick in a slider for our input and vary it, and look at when the output reaches that 0.9, 0.95, and 0.99 benchmarks. In Stardew, you can use sprinklers to water your plants, and I can project that I'll have a whole bunch of these quality sprinklers that water 8 plants at a time. So I'm rounding the numbers that we got to multiples of 8 so that I can measure in numbers of sprinklers instead of crops. And ignoring little small patches of blank crops, we can just count out 5 or 6 or 7 sprinklers worth of melons to get that 90, 95, or 99% chance of success. And not bad, it doesn't take up that much room. So this math should apply the same to both the corn and the melons, right? Well, no. let's add in a few more details of what's actually going to happen on my farm that will adjust the numbers. First off, melons grow in 12 days, whereas corn grows in 14. And also, because this is a speed run, I am going to be using some speed grow to make them grow more quickly. So melons will grow in 9 days, whereas corn will grow in 10. I'll also be growing a considerable amount of starfruit, and with speed grow, they grow at the same rate as melons. And after harvesting all of that starfruit, my farming level will go up considerably. So whereas on the first harvest of melons, I'll expect my farming level to be 6, and then with the farmer's lunch, it'll be 9. After harvesting those melons and starfruit, I'm expecting my base farming level to go up to 9, and with a food buff, it'll be up to 12. So we do need to adjust the math based on this new probability, 25%, at farming level 12. And I think it's important to just double check that this whole farmer's lunch thing is actually going to work. So let's make the dish, eat it, get that farming buff, and after harvesting all of this ancient fruit, I do get 162. Restarting the day and doing basically everything the same except for eating the dish, after harvesting all of the ancient fruit, I only get 128. So we can change the outcome of the same day by eating a dish as we're harvesting the crops. So with this new probability number in hand, knowing for sure that it'll be 25%, I can see that the chance of getting 5 gold star corn is way higher than 5 gold star melons with the same plots of land, which makes sense because I'll have a higher farming level once I'm harvesting the corn. And we can get the same benchmark numbers for 90, 95, and 99% confidence and bring them back to the whiteboard. These numbers don't round as easily to multiples of 8, but we can see that on the farm diagram, the corn is definitely taking up less space than the melons. Okay, now we're done, right? No, there's one more in-game mechanic that I haven't included in my mathematical model. Well, there's more than one, but this is the last one I will include. If you're allowing yourself to reset days, you can first go out into your field and figure out which crops are gold star, and then reset the day and only select the gold star crops. Then, the next day, the rest of the plants that you left on the ground will re-scramble their probabilities, and the ones that you didn't pick, the ones that were certainly not gold yesterday, will then now have a chance to be gold star quality the next. So, because I will be able to harvest the melons one day before the corn, I do have the option to use this strategy, exploit, on just the melons. Also, as an aside, there is a way to harvest the melons 2 days before the corn, but I'm not doing that. So anyways, if you have the agriculturist profession, you need to do something different. Here I'm using a similar strategy as before, where I think it's a little bit easier to count the failures and do 1 minus failures, instead of trying to count all the different possible ways of getting a success. I'm also going to use a little bit of a grid here to just visualize the different ways to fail. Along one axis, I'll have the number of gold star melons I'll harvest on one day, and then on the other axis, I'll have the number of gold star melons the next. And as long as the total is not 5, then this is a failure. So for example, we could get like 0 melons on the first day and 0 on the next, or we could get 2 and 2, or 4 and 0, and all of these are potential outcomes that cause failure. So let's start to work on these 15 scenarios and find their probabilities. We probably just can multiply the probability of one failure times the other one, and do that for all the different outcomes. And pausing here, I will talk a little bit more about what I mean by independent events. In math, when you do have independent events, you can multiply their probability to get their shared probability, one after the other. However, when there is dependence involved, when the probability of one affects the other, you can't just simply multiply the probabilities. Now, this is just a mathematical model, so I'm fine allowing myself to assume they're independent. However, they might not be. It's totally possible that if one crop is gold, the nearby ones won't be. Or it's possible that the quality of these crops is determined by some kind of feature on the map, and there's an underlying way that the random number generation is made. I don't know. So this is kind of where I'm leaning more towards the math than the actual game mechanics, just because, hey, this is Math with Patrick, not Stardew with Patrick this time. Ultimately, when we write out all the products of these probabilities, tallying up the probability of that first column, we can factor out that first number, because that number, that probability of getting 0 gold star melons on the first day, is the same number for all of those scenarios. So we can factor that out, and we get some kind of sum on the right side. Then we can do the same thing in the scenarios that we get 1, 2, 3, or 4 gold star melons, and then our sums on the right are shrinking a little bit just because we can't, again, get like 4 and then 4 melons. So if we get 4 on the first day, there's only really one thing that's happening on day 2. We get none. We also have to be a little bit careful about the interdependence of the number of crops we have on the different days. Because, for example, if we harvest 1 melon on day 1 versus, say, 3 melons on day 1, we're going to have a different number of total crops on day 2 in those different scenarios. So as we create our expression and our sum, we do have to make note that the day 2 total number of crops is changing depending on what happened on day 1. And like before, I don't need to use summation notation here, it's just that I'd rather, because it is a little bit more concise than writing out the sum of 15 things. First off, I am using 2 different probabilities here because my farming level is going to be different on day 1 and day 2, right? Because it's 19% when I'm harvesting the first set of melons, and then it'll be 25% on the next day. Secondly, I have that same 1 minus setup as before because, again, we're counting the scenarios that cause failure, or the probability of those scenarios. So doing 1 minus the probability of failure will give us the overall probability of success. And to see this expression in action, let's just pick a certain value of j, let's say 2, and just run with it and see what happens. This represents the scenario of us finding 2 gold star melons the first day, harvesting those, and then waking up the next day with another reset field of potential golds. However, in this scenario, we can only pick up 0, 1, or 2 gold star melons from this reset field, because those are the scenarios that'll cause failure for us. By including the j incrementer in the expression on the right, I'm able to do a few things. I can cap out the sum at 2, which represents the up to 2 melons we can harvest while still failing. And I can include the j in the choose function there, which represents 2 fewer crops being grown in the field. And then I can include the j in the exponent at the end, which represents the 2 fewer non-gold star melons that I get. Gosh, wow, I'm really running out of space here on the right. Anyways, with this new expression, I can figure out, for my particular scenario, how many melons and how many corn I need to grow. The number for melons is 24, and for corn it's 40, and both of those will give me a 98% chance of getting at least 5 gold star of each type. So now I finally know how much space I should allot for my melons and my corn, and this leaves me with plenty room for all of my other summer crops. And with each individual one being 98% certain, then, again, assuming independence, I can say that I have a 96% chance of moving forward with this run and being successful. And even if I do fail, it's actually not that bad, because I can use the same harvesting trick from before, where I just target the golds and then re-harvest the crops on the next day. So even if it fails, I'm almost certain that all I'll need to do is wait 1 more day. Thank you so much for coming along and exploring this probability question with me. I'll see you in the next one. Bye!